Hi everyone, welcome back to another Math 9 video. We are doing adding and subtracting fractions, which is 3.3 today. And so I'm going to start off with this example first that has the same denominator. So we're going to start off nice and easy with something you've seen and done before. So if the denominator is the same, we would simply rewrite the denominator and it's less work for us. We just have to add the top in this case. So 4 plus 3 is 7. And so if we end up with 7 over 7 in our first example, this simply just simplifies to the number 1. Okay, so in that case, we started off nice and basic with something you already know. Let's say we have 3 over 11 plus negative 5 over 11. Okay, so again, the nice thing for us in this case is that we already have the same denominator. So in my answer, I can already write over 11 with the same denominator. And at the top, I just need to practice my integer skills. So if I have 3 plus negative 5, I'm taking 5 away from 3. So on the number line, I'm moving towards the left. So 3 minus 5, I know that if I have minus 5, my answer is going to be negative. And the difference between 3 and 5 is 2, so I could say negative 2 over 11. The other way you could look at it is just if you if you had 3 of something, if you have $3 and you owe someone $5, that means that you can give them the $3, but you still owe $2. That's another way to look at it. So negative 2 over 11 is what we would end up getting in this first example. Okay, so then moving on, if we have negative 2 over 5, and I want to take away from that negative 1 over 5. So notice the pattern of what I'm doing. I started off pretty basic, both positive, same denominator. Then the next one I brought in 1 negative, and now I'm bringing in a bunch of negatives. So we go step by step, one thing at a time, and we're going to continue to do that throughout the whole course. So I hope that you find it manageable as a result of that step-by-step approach. Okay, so in this example as well, we have the same denominator. So part of the work is already done for us. I can write the answer with the same denominator. And what I'm going to do is take a look at it and say, okay, if I have minus a negative, I know that that's the same thing as me just saying that it's a plus. So I can go ahead and add them together. If I have negative 2 plus 1, that still leaves me with a negative. So it's going to be negative 1 over 5 as my end result. Okay, so for the next one, I want to practice something that I already showed you, and that is converting. If I have something like 5 and 2/3, and I want to change to an improper fraction. Okay, so this I think might be review for you, but it's okay if it isn't because I'm going to walk you through it step by step as always. So if we have a mixed fraction or a mixed number like 5 and 2/3, here's how we go through this. I'm going to color code these. So I'm going to use that for that, that for that, and that for that. So the reason I use the colors is for organization so that it makes it easier for you to follow along and understand. Okay, so if I want to change this to an improper fraction, which by the way is a fraction that has a bigger numerator than it does a denominator. Okay, so the way that I would do that is I would take the 5 and I would multiply that by the 3 that's at the bottom, and I would add 2 to it. So I'm going to repeat that. I would take the large number, the whole number, and I would multiply that by the denominator, and I would add whatever's on top. That's how I get the new numerator. And then the denominator stays the same. So if I had a 3 down here, I'm still going to have a 3 at the bottom in my new improper fraction. So I guess I can rewrite it that way here. And at the top, well, 5 times 3 is 15, plus 2 is 17. So I would get 17 over 3 as my improper fraction. And we could go the other way around. If I want to change this back to a mixed number or check to see if this is right, here's the way that I would do that. Well, I would do this. I would do 3. So this is us checking to see if we've done this right. I would do 3 into 17. And I would say, okay, how many times does 3 go into 17? Well, I know 5 times 3 is 17. So I'd get 5 at the top. Then I would do 5 times 3, which would give me 15. And I would subtract these, and I'd get a 2 down here. So to make this clear, in my original question, 5 is the whole number right here. 3 is the one we had here. And the 2, the thing that's left over, or the remainder at the bottom, is the numerator up here. So this allows us to go forwards and backwards to change from a mixed number to an improper fraction, or the other way around, improper fraction to a mixed number. So I hope that you found that helpful to be able to figure this out. And let's go through just another couple of examples that are similar to this. Let's say we have 4 over 9 minus negative 2 over 3. And I want you to add these together or subtract, however you want to look at this. But this is a little bit different than what we just finished doing because I don't have the same denominator this time. And that's okay because we can get the same denominator. So if we look at this, I could say, well, I have a 9 at the bottom here and I have a 3 here. So I need to multiply the top and the bottom by the number 3. That was not the best choice of colors. I pictured that going way differently. So if I want to get a 9 there, I'm going to multiply the top and the bottom here by 3. So what I'm going to end up getting is 4 over 9 minus, well, if I have minus minus, I'm just going to change it to plus. So I hope by now you're okay with that. And here I'd have 3 times 2 is 6, and 3 times 3 at the bottom is 9. So after doing all this, I end up with 10 over 9. And to make this clear again and to practice the skill we just learned, 9 goes into 10 one whole time. And then I would have 1 left over, and I keep the same denominator, which is 9, and that's how I get my end result or my answer. I would say this is the same thing as 1 and 1 over 9. Okay, moving on. We want to find the LCM of 18 and 32. Finding the LCM of 18 and 32. So let's start with something that I believe you've probably done before, and if not, don't worry about it, you're going to learn it now. We're going to do some factor trees. So we want to break these numbers down into factors. So I think what times what gives me 18. First thing that comes to my mind is 2 times 9. There's other stuff I could have used, but 2 times 9 is the first thing that came to mind. I'm going to circle the 2 because it's a prime number, and that's what we're trying to break this down into, all prime numbers. 9 can be broken down into 3 times 3, so I'm going to circle those as well. I can rewrite this as a product of prime numbers. So it's 2 times 3 times 3, or I can say 2 times 3 squared. And I'm going to put this in a little box because we're going to use this eventually. I want to do the same thing with this. 32, okay, there's different ways I could get to that, but the first thing that came to my mind is that this is 8 times 4. It's the first thing I thought of. Okay, well this is 2 times 4, and so now I have a prime number there, and this is 2 times 2, so I've got a bunch of prime numbers there. And this one's also 2 times 2, so I have my prime numbers there. So this is all just organizational stuff. I'm using these tools to basically keep myself organized, and I feel like math, 50% of it, actually I would say all of school, I would say life actually, is 50% just good organizational skills. So find your method of whatever works for you. But if this works well for you, then I would say use the different colors, keep things organized this way. But as soon as you make everything messy and you're all over the place, you're going to find that it's much harder for you. So a good way for us to write this is, well, I have 1, 2, 3, 4, 5 2's that are being multiplied. So that'd be like saying 2 to the power of 5. Okay, so we broke it down into a product of prime numbers. So to find the LCM, this is what we do. I line up my numbers here, like I would compare them, and I look for the ones that have the same base. So I have a 2 to the power of 1 here and a 2 to the 5 here. I need to take the largest exponent that's there. So if I have a 2 to the 1 here and a 2 to the 5 here, it's the 2 to the 5 that I'm going to use in my calculation. Okay, so then I move on to the next value. So in the next value, I would say times, well, there's a 3 squared that shows up there, but there's nothing else that shows up in this one. Even if there is no 3 here, I still need to use it. So I'm going to use times 3 squared. So I take all the bases that are present need to be included in my LCM calculation. And when there's a 2 in one of them and a 2 to the 5 in the other one, I take the largest exponent, and that's the one that I'm going to count. So when I go through this, well, 2 to the 5, I'm going to write it down here. That's the same thing as 32. And 3 squared is the same thing as 9. So basically, to get my answer here, I'm doing 32 times 9. And I don't want you to necessarily sit there and do this all by hand, but you could multiply it out. It would be 288. So we could sit there and go, okay, 32 times 9, 9 times 2 is 18, and we can see how we're getting 9 times 3 is 27. I add the 1 up there, and that's how I got this 8 down here. So you could quickly do that by hand, because our goal is to be able to do this stuff without a calculator. If you absolutely feel like you have to have it or need it, you can use a calculator, but I feel like most of you will be okay without and you won't need it. So I hope that that's helpful in figuring out how to calculate the LCM, but I do think that maybe one more example is going to be helpful. The LCM of 12, 16, and 18. And so, well, maybe I'm just going to be lazy and do my factor trees here. That would be 4 times 3. That would be 2 times 2. So when I go to do my product of prime numbers, for this one I would get 2 to the 2 times 3. I'm going to do the next one in a different color so we can keep track of it. This would be 4 times 4, and this would be 2 times 2, and this would be 2 times 2. So I would end up getting 2 to the 4 in this case, which maybe you already knew, but that's okay. We went through it. Here we'd have 2 times 4, and here we'd have 2 times 2. So this one ends up being 2 to the 3. Okay, so now that we have the 3 of these lined up, to calculate my LCM, I would look at all of the numbers that have the same base. So the 2 to the squared, the 2 to the 4, and the 2 to the 3. And I take the largest one that's there. So if I look at it, 2 to the 4 is the largest one. So that's the one that I'm going to include in my calculation. Okay, so for this next one, I'm running out of colors. Actually, let's use, will that work? It's kind of sparkly. I don't know if it's working, but for the next one, when I look at it, this one has a 3, but the other ones don't have a 3. I need to include the 3 because anything that's present in there needs to be included. So if I take a look at this, 2 to the 4 times 3, which is, well, 2 to the 4 is, so this one here is 16. And then I'm going to do times 3. So after working on all of this and going through this, this would 16 times 3 would be 144. Sorry, what am I doing? It's not 16. Sorry, everybody. I have my numbers mixed up here. The last one was supposed to be an 18. I hope this isn't going to mess you up, but let's go back and fix that. This should have been an 18, which means when we go to break this down, it's going to be 2 times 9, which would be 3 times 3. And here I have 2 times 3 squared, which makes this a little more exciting to work with. So I want to show you. I initially started off with that being an 8. I have since changed it to an 18. So I did 2 times 9, and then this 3 and 3 to break down the 9. So actually what I get as a result down here would be 2 to the 4 times 3 squared. So I hope that you can go back in your video and revisit that and it didn't mess you up too badly. I just would rather have more to work with here, which makes it a little more interesting for you, because if we compare them, this one only has a 3, but this one has a 3 squared. So I'm going to take the larger one to include in my calculation, which is what I got here. So now hopefully I can redeem myself. 2 to the 4 is still that 16 that we had. And we're going to multiply that by the other one, which was 3 squared and is our 9. And when I do that 16 times 9, that's when I get my answer of 144 for my least common multiple, or my lowest common multiple, however you want to say it. Okay, so for this section, I'm going to have you do just all of the questions, but do the odd letters. So go through each of the questions and just do A, C, E, etc. You're skipping a letter. And I hope you found the video helpful.